The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. So today we are into the happy morning, students. I hope we have come to the last part of our academic year, that is the last chapter in chemistry, which is dealing with chemical reactions of organic compounds. Now, if you see, we have been learning organic chemistry right from the last chapter. Organic chemistry plays an important role because the preparation of organic compounds are being widely used in different fields in our daily life. You have medicines, you have polymers, or you have any synthetic items or in utensils, anywhere that we handle in our daily life, these organic compounds play a very, very vital role. So now, what are the reasons behind these formation of organic compounds? There are certain reactions which are responsible for the formation of these organic compounds. So let us learn some of the important reactions that are involved in the preparation of organic compounds. So we have 5 important reactions which are necessary. The first one is the substitution reaction. As we all know, substitute means somebody taking the place of someone else, right? We have a substitute in our games. When we play volleyball or throw ball or when we play basketball, there comes a substitute for somebody else. So here, substitution means the same, where in an hydrocarbon, where there is carbon and hydrogen bond formed, one of the hydrogen will be replaced by another atom. So what are substitution reaction? When an atom or a group of atom replaces another atom or group of atom in a reaction, we call those reaction as substitution reaction. Now let us see how does it work. Substitution reaction may also be called as chain reaction because it does not stop with one step, it continues till all the atoms of that hydrocarbon are being replaced. So let us see how does this reaction occurs. When we take an example here, methane, this is my methane CH4, when combines with chlorine in the presence of sunlight, I have 4 hydrogens here. So I write here hydrogen, hydrogen, hydrogen. One of this hydrogen will be combining with chlorine. One of the hydrogen will be combining with chlorine and comes out as HCl. So what happens? This place is vacant and this will be occupied by the chlorine atom. So the hydrogen is replaced by chlorine atom. So this is called as chloromethane, or you call it as methyl chloride. So methane becomes chloromethane. What happens in the second step? I have hydrogen, hydrogen, hydrogen and a chlorine atom. Again that reacts with chlorine molecule. So what happens here? So this is my hydrogen, this is my hydrogen, this is my chlorine. Now this hydrogen takes up this chlorine and the other chlorine will come and occupy the empty space. So this becomes chlorine and I have again HCl. So again the second hydrogen is being substituted by the chlorine and this is dichloromethane or methylene dichloride. So in the first step only one hydrogen is replaced. In the second step the second hydrogen is also getting replaced. Now let us see what happens in the third step. I have 2 chlorine atoms and 2 hydrogen atoms. Now this when reacts with chlorine in presence of sunlight, now the third hydrogen attracts the chlorine, comes out as HCl and another chlorine comes and occupy the hydrogen position. So I have hydrogen, carbon, chlorine, chlorine, chlorine plus HCl. So this is trichloromethane, or also called as chloroform, CHCl3, anesthesia which we use, right? So this is chloroform. And the last step is, I have one hydrogen that is left in the compound. So what happens now? Chloroform, the last hydrogen takes up this chlorine, and this chlorine comes and occupy the hydrogen position. So I get here carbon with all the 4 hydrogen replaced by chlorine atoms. So what do I get? Carbon tetrachloride, CCl4, or it is also called as tetrachloromethane. So this is how the substitution reaction takes place. To be precise, how can we write it in the simple form? To write it in simple form, I can write like this: CH4 plus Cl2 gives CH3Cl, and take out one hydrogen and make it as HCl. In the second step, CH3Cl again combines with Cl2. Now reduce one more hydrogen here, make it as CH2, add one more chlorine, becomes Cl2 plus HCl. Got it, children? The third step, CH2Cl2 will combine with chlorine again. Again I will reduce one more hydrogen and I will increase one more chlorine. So I get CHCl3 plus HCl. And what is the last step? I have one hydrogen that is left, which will again be replaced by chlorine. So I get CCl4 plus HCl. So when your answer is correct, when all the 4 hydrogens are replaced by our chlorine atoms. In example, you may not be getting to write the whole, but instead they may give you only the first step. CH4 plus Cl2 gives dash plus HCl. So you may have to write only CH3Cl. At that point you need not write the whole set of reaction. If they ask you to write the continuous step reaction, then you may have to write the whole steps. You are able to get me, children? Now we will learn addition reaction. Which we are going to see is addition reaction. If you see these two compounds, children, CH3 and CH2 double bond CH2. This is ethane and this is ethene. This is ethane, this is ethene. Ethane are saturated hydrocarbons. Ethene has a double bond and they are called as unsaturated hydrocarbons. What are unsaturated hydrocarbons? Which are made up of double and triple bonds. So when these unsaturated hydrocarbons, they undergo addition reaction in presence of nickel as catalyst, they become saturated. How they become saturated? The double bond actually breaks. When the double bond breaks, it becomes a single bond, thereby the adduct, whichever reactant we are getting added to these alkene molecules, they comes and attacks or joins the hydrocarbon. So if ethene reacts with hydrogen in presence of nickel as catalyst, the 2 hydrogens comes and occupy the carbon position. This hydrogen comes and attacks this reagent. What happens? 2 hydrogen comes and attacks the 2 carbon atoms. So one hydrogen forms here, one hydrogen comes and attacks here. So ethene becomes ethane. The double bond is broken and it becomes a single bond. Now same thing when we take propene, CH3, CH double bond CH2 plus Cl2, there are 2 chlorine atoms which will come and attack the carbon that is holding the double bond. So these products, that is with these reactants like hydrogen, chlorine, bromine, they comes and attacks the carbon where the double bond is present between them. So what happens here? This is my CH3, this is CH, I have one chlorine and another chlorine coming and attacking the propene molecule. So this becomes 1,2-dichloropropane. So such reactions we call it as addition reaction, where the added reagents comes and attacks the unsaturated hydrocarbon to become saturated. The double bond is broken and it becomes a single bond. With this substitution and addition reactions are over. Now we will learn about combustion, polymerization and thermal cracking. Now we'll see the next topic, that is polymerization. The name polymerization, polymers, which we have been hearing from lower classes, that is polymers. It has got a lot of application in our daily life. Now polymerization is a process where the simple molecules under high temperature and pressure conditions, in the presence of catalyst, they try to form a complex molecule. Similar simple molecules, they combine with each other, that is they get added to each other under very high temperature and pressure conditions in the presence of a catalyst, because catalyst is very important to initiate the reaction and to make the reaction faster. So in presence of a catalyst, they give complex molecules. If you see this example, this is my ethene. Now ethene, when it's gathered again and again, ethene gets added to ethene, another ethene on a continuous process, it gives a chain product like this, which is called as polythene. So instead of writing like this, let us put it in this way, n molecules of ethene. N molecules means it can be 5, 10, 100, 200 and so on. So n molecules of ethene, they react or they polymerize to become polythene. So when you are writing, you put that, you break the double bond, you make it single, put 2 hyphens on the bracket, put a square bracket and write here n. This n represents the n molecules of my monomer. So these simple molecules are called as monomer and they polymerize to give the product which is called as a polymer. So which is the monomer of polythene? Ethene. Or which is the polymer of ethene? Polythene. So ethene on polymerization will give me polythene. The next example is vinyl chloride. This is a vinyl structure. CH2 double bond CH, which is connected to my chlorine. So vinyl chloride, you have to memorize this, children. N molecules of vinyl chloride on polymerization, the double bond is broken, it becomes a single bond. Put 2 hyphens on the square bracket and write N here. So the other structures all remains the same. So this is vinyl chloride on polymerization will give me polyvinyl chloride. PVC, you know this PVC pipes have been used in plumbing and other purposes. The next one is Teflon. You know Teflon coating in utensils, you see in lot of advertisements. So Teflon is nothing but tetrafluoroethene. 2 fluorine here, 2 fluorine, totally 4 fluorine atoms. So tetrafluoroethene, because 2 carbon atoms are there with a double bond. So tetrafluoroethene, N molecules will polymerize to give Teflon. So you remove the double bond here, make it single and it becomes a Teflon. N molecules of Teflon will be obtained by polymerization process. There is a table given to you in the textbook, if you see. Monomer, polymer and use. So the monomer is not given, polymer is given, or the monomer is given, polymer is not given. Try to write the, fill in the blanks and also try to write the use which you already know that is used in the daily life. Now let us learn about combustion of hydrocarbons and then we will get back into thermal cracking. Combustion reaction. What is combustion? Combustion means burning of the hydrocarbons or burning of any reactant. Combustion is always done with the support of oxygen. So any hydrocarbon, when it is burnt in the presence of oxygen, it gives 2 important products along with heat and light. They are carbon dioxide and water. So any hydrocarbon, when it is subjected to combustion in the presence of oxygen, it gives carbon dioxide and water along with heat and light. And this reaction is always exothermic because lot of heat energy is being released. Let's take an example where methane undergoes oxidation, or I will say combustion in the presence of oxygen. It gives carbon dioxide and 2 molecules of water. You may have to balance the reaction, and you know how to balance. You have learnt in 9th standard to make sure that the number of carbon atoms or the number of atoms on the reactant side should be equal to the number of atoms on the product side. So this is how any hydrocarbon, when it is burnt in the presence of oxygen, will give us carbon dioxide and water. Now what is thermal cracking? When combustion takes place in the in the presence of oxygen. Thermal cracking is done in the absence of oxygen. That is, hydrocarbons with higher molecular masses, they get breakdown, or when they are heated in the absence of oxygen, they split into two hydrocarbons. That is, whenever a saturated hydrocarbon of higher molecular mass is subjected to thermal cracking, it gives two compounds, that is one unsaturated and one saturated hydrocarbon. And this cracking or the cleavage of the chain can take place in many number of ways. If you see a 3-membered carbon, that is propane hydrocarbon, splits into 2:1 ratio, that is double bonded ethene and a single bonded methane. Now let's see this example. I have a pentane, this is 5-membered. Pentane can undergo cleavage in two different ways. It can undergo as 3:2, where 3 can be an unsaturated and 2 can be saturated. A 3-membered carbon which is having a double bond is CH3, CH, double bond CH2, where I can introduce a double bond here. So this is a 3-membered. Now I have 2 more to get split into, where I can write as CH3, CH3, which is saturated. That is, one hydrogen from here get jump into the other side. So I get propene plus ethane. Or if I want the 3 to be saturated and 2 to be unsaturated, I can get CH3, CH2, CH3 propane plus an unsaturated, which is CH2 double bond CH2, that is a double bond, that is ethene. So thermal cracking is basically a process where a higher molecular mass hydrocarbon splits into a lower molecular mass hydrocarbon, with products being one saturated and other unsaturated. You have been given 2 tables in your textbook, page 125. Try to solve the table 7.3 and 7.4. First one is fill in the blanks, second one is match the following. Please do that so that we can discuss in the class the same. Next is some important organic compounds, maybe not that with exam point of view, but also you have alcohols. Under that, methanol and ethanol. Learn the preparation and 2 properties. Also about ethanol, the 2-step process, preparation and some of the uses and properties. Then you have carboxylic acid, where ethanoic acid is being given, and esters are also given to you. Esters, you have the COOR, and these are not given in focus point of view, so you can just learn from the textbook. And the last one is the soap, formation of soap and its application with detergents. So these are the things that are as important. So when we are in the class, we will be discussing about soap, detergents and other important alcohols also. So with this chapter is getting over, and once you come here, we are definitely doing the revision with respect to each chapter. So make sure that you are coming regularly to the classes. Thank you children. Have a great day.